So this organization asks these three questions. Must we change? Can we change? And then will we change? And it's breaking this presentation into three parts, although I don't really want to break it into those three parts. So don't worry about these questions. There it is. So this photo of the Earth, you're all familiar with this, right? You've seen this picture before. It was taken in the 1970s, the early 1970s. You're not taking notes about this. Just think with me, okay? Sometimes I would prefer that your fingers weren't moving, because then I can tell that you're thinking. This picture was taken in the 70s. We all know it. It was taken by the Apollo astronauts on their way back home from the moon. And it was one of the first times that people at that time had seen our entire planet in one photo. We're used to it now, huh? You guys grew up with it. But this was groundbreaking when it first appeared in the news. It changed people's way of thinking about the Earth. We look at it and we can see we're just this little blue marble floating in this black space, right? We're just a little oasis of life surrounded by nothing. If we have any troubles on our planet, do we have anywhere else to go? This is it, right? We are here. We don't have anywhere else to go. So how well do we need to take care of our globe? How important is it for us to take care of the planet? These are the kind of questions that people started asking when they first saw this image. Now, here's a more recent photo from the space station. And so the space station is orbiting the Earth, and it took this photo of sunrise. And what's really nice about this photo is you can see the entire atmosphere. How thick is our atmosphere? Does that look like a very thick layer around the planet? It's like, you know how thick the skin of an apple is around the apple? It's like that thick compared to the whole globe. So this is the first thing you should write down, is that our atmosphere is very thin. And that means it's easy to modify. It's very thin, so it's easy to change it. Here's another example to give you an idea of how thin the atmosphere is. If you were to drive a car from here to Sacramento, it's about 200 miles, right? It would take about 2 hours to get there, maybe 3 hours, depending on how fast you drove, maybe 4 hours. Actually, that's more like San Francisco, 200 miles, yeah. Right? You'd be there in 4 hours. If you drove your car, if you had a car that could go at the same speed, highway speed, 60 miles an hour, but you could drive straight up into the air, it would take you like only 2 hours and you would be in space. Okay, so the atmosphere is quite thin compared to the rest of the planet. And that means that it's fragile. But what are we doing to our atmosphere? We put our garbage in the atmosphere. And in this case, the type of garbage I'm talking about is anything that's gas that we don't want. Hey, Eli, will you shut off your microphone? So we're putting, they estimate 110 million tons of global warming pollution into the atmosphere every single day. Did I put some global warming pollution in the atmosphere this morning when I started my car? Yeah, I did. Are we putting some in it right now because we're using electricity? Well, I'm not, but the power plant that I buy the electricity from is, right? Unless it's a solar plant or a wind farm. Yeah. So every 24 hours, this seems like a huge amount to me. Doesn't that seem massive to you? So check this out. This is a surprising number. I want you to think about a gallon of water. How heavy is 1 gallon of water? Well, is this a quart? No, this is almost half a gallon. So here's this 2-liter soda bottle. If you had 2 of these, that would be a gallon. And that's about 7.5 pounds. How heavy is a gallon of gasoline? Heavier or lighter than water? Think about it. Which one would float on top of the other? Whichever one's going to float is the lighter one, huh? Yeah. So gasoline is slightly less mass than water. So let's say that a gallon of gasoline weighs about 6 pounds. This is crazy. When you burn that gallon of gasoline, 6 pounds of gas, it makes 22 pounds of CO2. How is that possible? So 1 gallon of gas, every time you burn it, releases 22 pounds of CO2. Now, for most cars, that's every 20 or 30 miles. You're releasing another 22 pounds of CO2. That's almost a pound of CO2 for every mile, isn't it? Unless your car gets really good mileage. So how is it that this 6 pounds becomes 22 pounds? Well, because when you burn it, you have a chemical reaction that combines the gasoline with oxygen from the air. And those oxygen atoms also have mass. So when we have this chemical reaction of combustion, you burn the gasoline, it combines with oxygen. That's what we're talking about. That's the O2 and the CO2, huh? The carbon came from the gasoline. The oxygen came from the air. So when we burn gasoline, we're putting every gallon puts 22 pounds of CO2 in the air. So the better your car's mileage, the more efficient your car, the less CO2 you're putting in the air, huh? Does that make sense? Okay. Now this video, it's a little video and it goes, I think, too fast. So I'm going to back it up and start it over again. At least I'm going to try. I think it's going to replay. Okay, so let's look at it. Okay, so let's review this greenhouse effect, you guys. And I'm sorry, this is just going to play through here pretty quickly. To start with, we have the light waves coming from the sun, and they go through the atmosphere, right? Are you thinking? This is on the test, I swear. You got to think about it. You got to know it. You should be able to tell me what's going to happen next. Notice these are short, narrow waves. What happens to them when they hit the earth? The light waves become, they become heat. The energy is absorbed by the earth. What's going on with this thing? The energy is absorbed by the earth and the light turns into heat, right? And we're going to see those become longer waves. And most of that heat is escaped back to space, but some of it gets trapped by the atmosphere and bounced back. Huh? That's greenhouse gases trapping it. And as we add more greenhouse gases, we trap more and more of that heat. It's like putting more and more layers on top of our bottles, huh? If we wrap those bottles up in even more layers of plastic, don't you think they would have been even hotter inside? Right? So did you see the atmosphere just get thicker right there? It's a subtle little thing. Look how thin the atmosphere is naturally. And then we're going to add CO2. We trap some of the heat right here, but watch it get thicker now. See that? That's the CO2 and the other GHGs that are trapping more heat than the natural greenhouse effect. Okay, so where is all this Carbon dioxide and other greenhouse gases, GHGs, where are they coming from? They're coming from all these things. All of these add carbon dioxide, methane, CFCs to the atmosphere, right? Industrial processes, coal mining, agriculture. Didn't I mention that cows release methane, right? So cows have a digestive system where they eat a ton of grass and they have to hold that grass. They actually have 4 stomachs. So the cow digests that grass in their first stomach. Meanwhile, methane is being released when they digest it and they burp that out. And then it goes to their next stomach, and their next, more and more methane is formed. And when it gets down to the other end of their digestive system, the methane comes out the other end. So burping and farting, cows produce a fair amount of methane. Are there more cows on the planet today than there were 1,000 years ago? Yeah, because people breed lots of cows to grow food, don't we? So one way to reduce greenhouse gases, go vegetarian. Meatless Mondays. The less beef you eat, the lower your impact on the greenhouse effect. The less carbon you would put into the air. Landfills, as these things decompose, they produce methane. We talked about that with permafrost. Right there, huh? When it thaws, things rot. Same things in the landfill. Driving, land transportation, burning crops, burning forests, air transportation, all of these add CO2 to the air, huh? So this is where the problem is coming from, largely human activity. So what's the number one source of global warming? Fossil fuels. And this is showing the amount of fossil fuels that have been burned. Maybe you want to write that down on your notes. What's the number one source of, you just say GHGs, if you remember that means greenhouse gases. The burning of fossil fuels, the number one source of global warming pollution. We can see the amount of fossil fuels and the amount of carbon they've released since 1850 has dramatically increased. Billions of metric tons of carbon on the y-axis. So in 2016, when this PowerPoint was made, 10 billion metric tons of carbons were released. Next, we looked at this graph already. What does this graph show? What's this 0 line down the middle? What was that? That was the average temperature, good. And what are the blue bars going down? Those years were colder than average, huh? And the red bars going up? Warmer than average, huh? So we can see that the average temperature is climbing. Check this out. 16 of the 17 hottest years on record have occurred since 2001. The hottest ever measured 2016. But wait, this PowerPoint was made in 2016, so it doesn't include any data for the last 5 years. So when it was made, I think it's even more dramatic, huh? Is that climate or weather? If I'm saying these kinds of things, is that a statement about climate or a statement about weather? Hello? Come on, take a risk. Is this climate or is this weather?
Climate.
Yeah, this is climate, absolutely. If we're talking about average temperatures for the entire year, it's climate. All right, so now this PowerPoint has 2 main things I want you to make lists about, okay? So I would like you to make a heading for your first list that is impacts of climate change. Impacts of climate change. In other words, what could it do to us? And this is an example in Boston, which we don't usually think of as a very warm place, where there was a heat wave and this person had heat stroke and had to go to the hospital. So can we have more heat-related illness as a result of climate change? Yeah, that's number one on this list, is more people could get heat stroke, heat exhaustion, heat-related problems. Heat stroke is strong enough that it can kill you. Next, number two, warming oceans. How do you think that the fish are going to like it if their ocean is warmer than it used to be? They're going to have to migrate somewhere else, huh? And maybe the fish can, but don't you think there's probably some small creatures that can't really go anywhere? So number two was the warming oceans. And again, we can see on this graph how the average ocean temperature has increased over time. So this is the temperature of the ocean, not of the air. And actually, we're especially concerned about this because a lot of the CO2 that heats up the air, that temperature, that heat goes right into the sea, goes right into the water. And the water can hold that heat for a long time before releasing it. So actually, the planet may have warmed more than we think it has because we only look at air temperature and not ocean temperature. We should be looking at both. And what did I tell you? As we warm the water, what happens to the space that the water takes up? It expands, yeah. And what does that do to the sea level on the beach? It rises, exactly. All right, here's the other issue with warmer ocean temperatures. More storms, more tropical storms. More tropical storms and stronger storms. So what does this have to do with warming oceans? Well, the energy in the ocean is what drives these storms. And this is amazing. This photo, taken from a satellite, shows 3 hurricanes at once, all category 4s near Hawaii at the same time. So for a number of years, we've named these big storms. If they get big enough, they get a name. And when hurricane season starts around June or July, they start naming the big storms. And they start with the letter A. The next storm is B and C and D. They used to only give female names, like Katrina. And then they started adding male names, like Hugo was a big storm that hit the east coast of the US. Last year, there were so many named storms that they ran out of the alphabet. They went past Z. I think it was Rose, but Hurricane Rose. So last year they went past Z and they had to start using the Greek alphabet. So after Hurricane, I don't know who Z was, maybe it was Zoe, Hurricane Zoe. After Hurricane Zoe, they had to go Hurricane Alpha, Hurricane Beta, Hurricane Gamma. That's how many named storms there were in the Atlantic last year, not even counting the Pacific. So this is our next possible impact. Did you write down more tropical storms and stronger storms? Because they get their energy from the ocean. So you guys already know about the water cycle, right? Think about what warming the planet could do to this. If we warm the planet, how much evaporation would we expect? We warm the planet, how much water would evaporate? We have more water evaporate? And if there's more water in the air, how much of it is going to fall down to ground? More, right? And if there's more precipitation falling to the ground, how much water is going to be flowing downhill? And how often might that water overflow the riverbanks and flood the surrounding landscape? With me on this? So if we change the temperature, we can change the hydrological cycle. We can increase the amount of water moving from air to land again, right? We evaporate more, so more rains, so more goes downhill, and we can have more floods as a result. What are you supposed to list on your paper? The possible impacts, the possible results. So we're thinking there could be more rain like this in Montana. I think that's a beautiful, frightening picture. We could have more rain and more intense rain, and we could have more floods. Those are both possible impacts of a warming globe because we're lifting more water out of the ocean all the time. It has to go somewhere. It's going to fall back to land, huh? And that's going to create these floods. That's not even counting floods from sea level rise, right? This is rivers flooding. Okay, not only do we get more evaporation in the ocean, but we also get evaporation from land because the soil has moisture in it, right? And hot days, water is pulled out of the soil. Could we, as a result of climate change, have two things going on at once? In one place, we have more evaporation that causes more rain and flood in one area, but in another area, could we have a longer drought? Because we're pulling moisture out of the soil and we can't grow our crops there. So is this another impact to add to your list? More droughts? Look at this. This is in Brazil. So, can you see, there's water in the background, right? It used to be that this lake was up here and this was underwater. So this was all mud, huh? And then as the drought continued, the lake got smaller and smaller, and the mud dried out. And when mud dries out, it cracks into these shapes. Maybe you've seen that in other places before. Even in Washoe Lake, just down the hill from us, you can see this on the sides of Washoe Lake. When the lake level drops, mud dries out and cracks. So we can expect to see more droughts as a result of global warming. And this is a big one for us right here. If it's hotter, we can expect to see more wildfires, huh? That's a major issue for all the western states, especially for people that live in a forest. Know anybody that lives in a forest? So notice
I live in a
that
forest, Mr. Fairley.
notice that the number of fires has increased quite a bit between 1970 and 2015, huh? We've had more wildfires. And we think that's related to higher temperatures and drought. If the trees are dried out because they didn't get enough water in the wintertime, then they're more likely to catch fire later on. Here's a photo of a big fire in Canada. And what's scary to me is all these people trying to get away from it, stuck in a traffic jam. So think about this, Lake Tahoe, Incline Village. What if there's a fire that starts in Incline Village and we're told to evacuate? Yeah, maybe you go to the water. Do you have a boat? Lucky you. I don't. Well, I have a kayak. I could launch my kayak. So if you don't have a boat, this isn't really an option, right? I have a kayak, so I could launch my kayak. But here I am paddling my kayak, and I'm trying to paddle through smoke like this. I'm going to have a hard time breathing even out on the water, huh? Okay, so if there's a fire, maybe going to the water is an option. But if it's not an option, what do? You only have three choices. You go to Kings Beach, you go to Carson, or you go over Mount Rose, huh? Those are the only ways out of Incline, huh? And what if the fire is blocking one of those ways out? Then you got to go to the other one, right? But what if you have a traffic jam like this and you're not going anywhere? And then the fire catches up with you. And I know we're laughing about it, but this happened to people. Did you hear about the fire in the town of Paradise in California? a couple years ago in November, there was a fire that came to their town so fast because of the wind that people got stuck in a traffic jam and 80 people died. The most deaths in a fire in California history. 80 people died in this little town because the fire got to them before they could get out. So this is a problem for us, isn't it? It's a real issue. I think for us here in Incline Village at Tahoe, the biggest problem with climate change, besides maybe not being able to ski as much, is the potential for forest fires. So what do we do to avoid this problem and stay safe? First of all, should you be out there playing with matches? I remember when I was a teacher at Galena, there was a fire that was started out in the desert by some kids that were like tying matches or firecrackers to lizards, which is pretty cruel in the first place. But then the lizard runs away and starts the grasses burning, and starts a wildfire. When I lived in Carson City, there were a bunch of high school kids at this waterfall, a beautiful spot, and they had a big campfire. They're having a party, sounds fun. But they let their campfire get out of control, and it spread and destroyed something like 20 houses because these kids were partying irresponsibly. You don't need to have a big giant fire, right? So that was irresponsible. Other things that can start a fire accidentally are really silly little things. Like if you're working in your yard, sometimes you can create a spark, which starts a fire. So you really got to pay attention to what you're doing. If you're driving somewhere, your car engine gets hot, right? And if you park in tall grasses, your car's engine can light them on fire. So there's many stupid things that people do that start fires, right? Lightning is another issue. We don't have any control over that, do we? You and I also don't have control over some of the more recent fires, like the big fires that started in Napa a couple years ago. Those were caused by the wind that knocked down the power line. And so here's this electrified wire on the ground sparking, and it lit the grasses on fire and destroyed many people's homes. So, first of all, be smart and don't start a fire, right? That's number one. Number two, how can you protect your house in case a fire does get started? Well, from the outside, the smoke alarm is to protect you from the inside, but to protect you from the outside, yeah, cut your grass. Should you have trees whose branches are leaning up against your home? Because if that tree catches fire, then it moves onto your house. So they call this defensible space, where you clear an area around your home, around your building, where there's nothing that could burn. 6 to 10 feet of defensible space around your house. Then if a fire does come in, first of all, it's less likely to catch your house on fire. Secondly, does it give the firefighters a place to work? If you give them a 10-foot gap, can they fight the fire from getting your house? But if you have bushes and trees right up against the building, is there any place for them to work and fight the fire? No, there's not. So that's probably the number one thing that you and I can do right now, is to maintain defensible space around our homes. Okay. So the next impact of climate change is an increase in extreme weather events. Is that what this graph is showing? Is it showing an increase overall of all these different kinds of extreme weather events? And they're combining extreme temperature, drought, and fire with floods and mudslides with storms. And we can see, especially if we add them all together, that the number of these extreme weather catastrophes is increasing over time. Did you add that to your list? More extreme weather events. Now, do we know that any one of these things is going to happen? Or are we just predicting that they're more likely to happen? It's kind of like, think of it this way. If you're a smoker, are you guaranteed to get lung cancer? No. But is it more likely that you'll get lung cancer than someone who doesn't smoke? Same thing here. Do we know we're going to have these extreme weather events? No. But is it more likely that we will? Yes. Oh, let's see what's happening to our glaciers over time. Let's look at that one again. What's happening to our glaciers over time? Look at this, 1935 versus 2013. The ice is completely gone, isn't it? And it's melted, and it's a beautiful fjord. I'd love to go paddling in there. But it used to be ice, huh? Right? So this graph is showing us the amount of ice that is melted off of Greenland since 2002. It's measured in gigatons. I think that is billions of tons. So the amount of melting starting in 2002, the amount of ice has gone down. Hey, wait a minute. Why does it go up every year and then back down? What do you think? The amount of ice in the wintertime, it's going to go up, huh? We get more ice freezing, and in the summertime, we get more melting. But overall, are we getting more freezing or more melting? We're getting more melting, huh? And we could make the same kind of graph for many different mountain ranges if we looked at the amount of ice that they have. So, did you write down that glaciers are melting around the world? That's another impact. Glaciers melt. Oh, here's a video from Miami. Does it look like a rainy, stormy day? So where's that water coming from? From where? From the ocean, yeah. So this is on an extreme high tide. Yeah, so here we are in September in Miami, and the sea level has gone up. So is that another impact to add to your list? Sea level rise? Which cities are most at risk from sea level rise? Well, there's different ways to look at it. This graph, number one, is Miami, huh? What this graph is looking at is not how big the city is, but they're looking at how many dollars of damage they are risking. So this is estimate in dollars, in trillions of dollars. So if Miami gets flooded by sea level rise, we're looking at $3.5 trillion in damage. So this is in dollars of damage. Miami's number one. Guangzhou in China is number two. New York, number three. This is in India, China, India. I'm not sure. I think China, Japan, Hong Kong, Thailand. But there's another way to look at this. What if we look at it by the number of people that are at risk? Here's the same graph, but looking at the number of people that are likely to be impacted by sea level rise. Now we have India, Bangladesh, right next to India, China, Vietnam, China, Thailand, Burma, Miami, United States, and then Cambodia. So a lot of these cities that are at risk of flooding are in Asia, right? And that's just because the landscape is flat for miles as it approaches the sea. So if the sea comes up a little bit, it goes way inland and can destroy these cities. Okay. In 2014, this is a quote from the Department of Defense. Even the Army, Navy, Marines, and Air Force recognize that climate change will likely lead to food and water shortages. Is that one you should add to your list? Food and water shortages? Oh, pandemic disease. We've never heard about that before, have we? And disputes over refugees is another impact. We talked about that a minute ago. If the sea level rises and the island nations are drowned, where are those people going to go? If the sea level rises and floods Miami, where are those people going to go? Or floods Calcutta in India. Where are they going to go? So we might be seeing huge movements of large numbers of people as climate change moves into the future. And will those movements of large number of people always be welcome? No. Could that lead to disputes? Could that lead to all-out wars between people? That's why the Department of Defense is concerned about this. How about this one? Did you write down food shortages already? Okay. What about crops fail? Kind of related. But does this look like the kind of corn that you want to eat? Or that the farmer wants to grow? Right? So if the plants are being heat stressed, then that's a problem. Or if there's not enough water for the crops, that's a problem. So food shortages, crops not growing, another potential impact. Medical problems. That's kind of where we started with, was medical problems, right? But there's multiple ways that climate change could be considered a medical emergency. One is from heat stroke, like I talked about. Another is from tropical diseases that we talked about. The spread of pandemic diseases is another one. Now check this map out. Every time they're showing where a tropical disease starts, and then they're showing its spread. So all the stars are where it started, and then notice that they're all near the equator too. And then they can spread north and south because we have a warm enough globe that those organisms can live in those other areas. So these include West Nile virus, Rift Valley fever, chikungunya, Chagas disease, Cryptococcus gatii fungus, dengue fever, Zika virus. This doesn't even include malaria and yellow fever, which are also tropical diseases. Yellow fever is also spread by mosquitoes, and it used to be in the southern US, but we eradicated it. But it could come back as a result of climate change. In fact, there are some places, if you want to travel, like when I went to Brazil, I had to have a yellow fever vaccination before I could go. So this is the species of mosquito that carries Zika. There are many different kinds of mosquitoes. Some are used to cold climates, like the ones that live here in Tahoe, but others only survive where it's warm, and the ones that live where it's warm are the ones that tend to carry disease. But if we warm up the planet, then we have a warmer planet, we're going to end up with these mosquitoes moving to new places, huh? Okay. Here's another problem. Another potential impact is extinctions of many species. We think this guy, this golden toad, it's called, we think it's already extinct. They've not been seen for 10 or 20 years. These guys only lived at the tops of mountains in places like Costa Rica. And those mountaintops were always misty, always foggy. And that's why they're called the cloud forest, which means they had high humidity, right? But with climate change, there's been more days without the fog. And we think these guys, their habitat basically dried up. And it's closer to home than that. There's a cute little rodent called a pika that lives on mountaintops in the Rockies and the Sierras. And what these guys do, they're pretty cute. Imagine a little guinea pig that's running around, and it lives in the rock piles in the mountaintops, and it runs down to the meadow and gathers a bunch of grass and brings it to its rock little burrow, and it spreads out the grass to dry in the sun. And it does this every day, all day during the summer. And then in the fall, it brings all the grass inside the rock pile, so it has food to eat all winter. But of course, it's easier if you see your neighbor gathering grasses, if you just go steal some of those. So they have these little battles between themselves and stuff. And they used to live at Tahoe, including places like North Star, but they haven't been seen for a decade. We think that climate change has killed them off. And then we have all these potential costs of carbon. I think we've written down most of these, except I want you to add this one to your list, ocean acidification. Ocean acidification. So when carbon dioxide dissolves in the ocean, it lowers the pH. It makes the ocean a little bit acidic. And that's a problem, especially for creatures that make shells like snails and coral, because their shells dissolve in acid. The whole ocean is becoming a little bit more acidic. Not that it would burn you, not that it would even destroy the shell of an adult snail, but it might prevent a baby snail from making its shell. And if the baby snail can't make a shell, then you don't have any more adults, do you? So ocean acidification could be a big problem in the future. I think most of these we already wrote down though, didn't we? One way or another. So their argument is that we need to change. The question is, will we change? Can we change? So your second list is called solutions. So what are some possible solutions? Well, more green energy, more wind energy, for instance. Actually, the growth of wind energy is 16 times greater than we expected it to be. Now, does wind energy have some problems? It does, yeah. We can talk about the good and the bad here. Look how much wind energy has increased in the last 40 years. A lot more electricity from wind. Why is that good? Because it doesn't make CO2 to get the electricity. No CO2 produced, no burning of fossil fuels. Now, some people, one of the things they don't like about wind energy is they don't like the way this looks. They would consider it visual pollution. Yeah. On the other hand, if you're burning carbon, wouldn't that also be visual pollution to have that big smokestack putting out the plume of smoke? So I don't know that it's any different than that. Other people don't like the sound that these make. There is a problem with actually if they build these in the migratory pathway of birds, that many birds can be killed by these turbines. They actually get hit by them, especially many birds migrate at night. And if they fly, at this height, and this is in their pathway, they can get hit by these things. So yeah, there are some negatives of wind energy, but does it produce CO2? No CO2 produced, so that's a big benefit. Now, I will say one more thing about that before we go on. 2 weeks ago, when they had that really cold snap in Texas, some people blamed it. They lost electricity, right? Many people lost electricity for days and days, and some people blamed it on the freezing of the wind turbines. And it's true, some of those wind turbines froze, but number one, are there already wind turbines in cold areas that are weatherproof? Yes, there are. So on Texas, just get a weatherproof wind turbine. Number two, that only accounted for about 10% of the energy. Their natural gas burning power plants also had freezing problems from the cold. So most of their loss of electricity was not a result of problems with wind. But the oil and gas industry wants to defend their profits, right? So they're going to spread this idea. Next solution, more solar. And again, we're seeing a massive increase in the amount of solar that's being used. 75 times more than expected. Look how much the solar industry has increased in the last 40 years. At the same time we're using more solar, look at how the cost has come down. Right? That's one reason the use of it has gone up, is because its expense has gone down. Is it possible that in like a village that never had electricity, that we don't even need to hook them up to an electrical grid, that they can just have their own independent solar panels. And they would never produce greenhouse gases from this, would they? In Chile, look at this graphic showing how the growth of solar.
Oh, there.
Pretty dramatic increase in the amount of solar
Hey,
in
you're
Chile.
still going.
Yep, still going.
Well, how long does this stop?
There we go. Yeah, pretty dramatic increase in their use of solar power. So there is a ton of solar energy coming to the earth every day. If we could trap it all, which we can't trap it all, but if we could trap it all, we would capture enough energy in 1 hour to run the earth for a year. That's the potential of solar energy. That's how much energy is coming to us. Of course, what are some negatives? First of all, it takes up land for the solar panels, doesn't it? But what if you put solar panels on rooftops? You already took up that land anyway. What if you put solar panels above parking lots? Then your car is shaded too, isn't it? There are some other problems though. Do we get any solar power at night?
No.
None at all. Do we get it on cloudy days? Not much. So we have to have enough when it's sunny and we have to be able to store it, which takes us to solution number 3, which is increase the amount of electricity storage, which means batteries. We have to improve the amount of electricity storage. And one of the people working on this, or one of the companies working on this, is Tesla here in Reno. Have you heard about the Gigafactory? This huge factory they built in Reno that builds batteries to store electricity, mostly for their electric cars, but for other uses too. So in the past, it used to be that if you had solar panels, you would need a battery about the size of a car to store that electricity. That takes up a lot of space, doesn't it? The batteries Tesla is making are about the size of this smartboard, and they do hang on your wall. So do they take up space anymore? Not like they used to. Like you had to have part of your garage dedicated to a battery. Now you just hang the battery on the wall. So that's a big improvement. Next one, use low energy lighting, LED lights. We're already seeing that solution spreading. We're using less energy for our lighting. Next one, get an electric car. I haven't even heard of a bunch of these different companies, but all these different companies are making electric cars. This was in 2016, so we might even see more now. Now, the electric car is going to have the best impact if you're powering it from solar or wind power, right? If you're powering your electric car from burning coal to make the electricity, then it's not as much of a benefit. But the analysis that they've done is that it is still better than a gas burning car. So, can we change? Are there solutions out there? Yeah, there are solutions out there. It's just a question of whether we're willing to do it, right? Will we change? Have you heard about the Paris Agreement? The Paris Climate Agreement. So in 2015, almost every country in the world agreed to reduce their production of fossil fuels, to reduce their production of CO2. 2015, and including the US, we signed on to this as well, and we set goals for ourselves to reduce our production of CO2. Now, was our goal the same as every other country's goal? It wasn't, for a couple of reasons. One, we produce more than a lot of other countries. Two, we've been producing it for longer than other countries. So our goals might have looked unfair to some people because they were expecting us to drop our CO2 production that much, and maybe they expected Kenya to reduce its CO2 production by that much. So it looks like we're contributing more, huh? But we already made more CO2 than Kenya did. That's part of the argument, is that we should take more of the responsibility for the problem because we created more of the problem. At any rate, people that didn't agree with this were elected to run the country in 2016. And so President Trump took us out of the Paris Agreement. And we weren't going to follow those goals anymore. We weren't going to try to meet those climate goals. In fact, we were going to drill for more oil in more parts of the country than we had before. Well, last January, when Biden was inaugurated, on the first day he was in office, he rejoined the Paris Agreement to try to reach those climate goals again. So that's something to consider when you're in the ballot box. 2017, there was a big gathering of people that marched for the climate, not only in Washington, D.C., this was all around the world. The People's Climate March. We even had them up here, I think in South Shore in Reno, had a climate march. So, this is trying to convince you to take action on your own. Use your voice, use your vote, use your choices. Like, are you going to choose to buy an electric car? Or are you going to choose to buy a big Hummer? Or are you going to not buy an electric car because you can't afford it, but you're not going to buy a big gas waster either? How many people actually consider how efficient their cars are when they buy them? Do people look at the gas mileage of the car very often? I know I do. I used to have a little Honda Insight that was a hybrid, and even after 150,000 miles, I was getting 70 miles a gallon in that car. So I only used 1 gallon for every 70 miles that I drove. I could drive from here to San Francisco on like 3 gallons of gas. So it was a very efficient way to commute, and I liked having that little car. Then I moved up here and I didn't need it anymore. But anyway, so I don't think I've made this assignment yet, so I'm going to make the assignment for climate impacts and solutions, and you just need to upload your notes when I do that, okay? All right, that's all I have for you today, so thanks for being here, you guys, and hanging in there. I guess I don't see you for like 4, 5, 6 days until Tuesday, right? So if you've fallen behind on things, I strongly advise that you look for my videos, because basically that's just like making up a class that you didn't come to, huh? All right, I'll see you guys later.
Thank you, Mr. Fairley.